Problems involving arithmetic sequence. In this tutorial, I'll be teaching you on how to answer problems that involves arithmetic sequence, with the exception of arithmetic series and arithmetic mean. So let's start. These are the first type of examples that we're going to answer. So let's proceed to number one. Find the a sub 40 of the sequence 9, 15, 21, 27. Uh, I want you to focus your attention on a sub 40. When we say a sub 40, we are asked to find the 40th term. So that is the that is what we need to answer in this problem. So let's check if this is an arithmetic sequence by subtracting the first term to the second term. So we have 15 minus 9 is 6, 21 minus 15 is 6, and 27 minus 21 is 6. So it has a common difference of 6, and therefore this sequence is an arithmetic sequence. Now let's remind ourselves with the formula a sub n is equals to a sub 1 plus quantity n minus 1 multiplied by b. So now let's enumerate the given. As we see, we have the given of 9 as our first term, and a while ago we solved for the common difference, which is 6. As you can see, I can say that n is equal to 40 because a sub 40, this is a sub n, then the value of n here is the value is 40. That's why we have uh, n as 40. And we don't have the value for a sub 40. Then after that, we're going to write the solution by first, we're going to solve this by first writing the formula, then substitute all the things that we have. So for our a sub n, we have a sub 40. For our a sub 1, we have 9. For our n is 40 and our d is 6. So after that, let's solve first what's inside the parentheses. So we have a sub 40 is equals to 9 plus 39 multiplied by 6. So let's multiply 39 by 6. So we have a sub 40 is equal to 9 plus 234. All we have to do is to plus 9 to add 9 to 234. So a sub 40 is 240. So that is the answer for this question. Now again, let's go to the next problem under this kind of problems. So we have find the 15th term of the arithmetic sequence 18, 22, 26, 30, 34, and so on. Again, 15th term denotes a sub 50. So we are looking for a sub 50 here. So now again, let's try to remind ourselves with the formula. Then let's enumerate the given. Let's start with the first term. The first term is 18. And if we compute this, we will get 4 as our common difference. So just subtract the two consecutive terms with each other. And we have n as 15 because again, this denotes as a sub 50. So we have our n value here, which is 50. And we don't know what is the value of the 15th term. Now let's solve this by first writing the formula. Then let's substitute all the values that we have. So for a sub n, we have 15. For a sub 1, we have 18. For n, we have 15. And for d, we have 4. Let's solve this first. What's inside the parentheses? So we have a sub 15 is equal to 18 plus 14 times 4. Then let's solve this 14 times 4. So we have 56. So a sub 15 is equals to 8 is equal to 18 plus 56. So that is 74. So the answer is the 15th term is equal to 74. Next, the arrangement of problem is different. So we have 2, 5, 6, some ellipses, and then 8 term. So we are asked to find what is the 8th term of this sequence. Again, the formula for our reference. Let's write the given. For the first term, we have 2. For the common difference, let's try to compute if it is 3. 5 minus 2 is 3, and 8 minus 5 is 3. So the common difference is 3. And because it is the eighth term, it is denoted by a sub 8. So therefore, the value of Rn is 8. Then a sub 8 is unknown. Again, for the solution, let's write the formula. Let's substitute the given. A sub 8 for a sub n, 2 for a sub 1, 8 for n, and 3 for d. Let's solve what's inside the parentheses. So a sub 8 is equal to 2 plus 7 times 3. Then let's solve 7 times 3. That is 21. So a sub 8 is equal to 2 plus 21. So that is 23. So the answer for this is a sub 8 is equal to 23. So this is how to answer this kind of question. Now let's go to another variety of question. So we have again a 3 example for this. Okay, so let's start with question number 1, and I will try to explain this in every question. In the arithmetic sequence 8, 14, 20, 26, 32, which term is 122? So if we write this sequence and it ends in 122, the problem is asking us is what is the place of this term. If this is a sub 1, this is a sub 2, a sub 3, a sub 4, a sub 5, then what is this a sub? So we don't know yet what is this a sub. So in this case, we will just consider this as our a sub n because we don't know what's the value of n for that. So let's remind ourselves again with the formula. Then let's enumerate the given. So for the first term, we have 8. For the common difference, let's check. 14 minus 8 is 6. 20 minus 14 is 6. 20 minus 26 minus 20 is 6. And 32 minus 26 is 6. So we still have the common difference of 6. Now again, we consider this as our last term or as our a sub n. So we have the value, we don't have the value for n, but we have the value for a sub n. So hopefully you got it. You got that on how we get these values as our given. Now for the solution, again, we need to write the formula, then substitute the value on that formula, then distribute this 6 to this n minus 1. So we have 122 is equal to 8 plus 6n minus 1. Let's eliminate the parentheses by multiplying them by positive. So we have 122 is equal to 8 plus 6n minus 6. Now let's combine like terms. I can see two like terms here. So we have this. Now our goal is to single out n so that we can get the value of n because that's what we are looking for, the value of n. So we have to do first is to eliminate this positive 2 here. Now to eliminate that, let's minus 2 here. So subtraction property of inequality. So if we subtract 2 here, we should subtract 2 on the other side of the equation as well. So we have 6n plus 2 minus 2 cancel. We have 6n left on the left side. Then 102 minus 2 is 120. So we can get the equation of 120 is equal to 6n. Now with that, let's divide both sides by 6 so that n will be singled out. So 6n divided by 6 is equal to 120 divided by 6. So that is n is equal to 20. So therefore, 112 is the 20th term or a sub 20. So that's the answer for this problem. Again, let's try on number 2. In the arithmetic sequence 4, 7, 10, 13, which term has the value of 301? Again, this is our a sub n because it's the place The term has, we don't know the place of this term yet. We know that this is a sub 1, a sub 2, a sub 3, a sub 4. But the for 301, we don't know yet. So let's solve for that. So the given is a sub 1 is equal to 4. The common difference is 3. And we don't know the value of n, but we know the value of a sub n, which is 301. Now let's solve this. Let's first write the formula, then substitute the value. 301 for a sub n, 4 for a sub 1, and 3 for d. Let's distribute 3 to n minus 1. That is 3 times n is 3n. 3 times negative 1 is negative 3. Then let's eliminate the parentheses. Then combine like terms. Let's combine 4 and negative 3. So we have this equation now. Now let's eliminate this one by subtracting 1 each side. We need to eliminate this one so that 3n will be singled out. So 3n plus 1 minus 1 is 3n. Sorry, minus 1 is 3n. And 300 minus 1 is 300. So that is our new equation. 300 is equal to 3. Now let's eliminate 3 so that the n will be singled out. So divide both sides by 3. So we have the value of n as 100. So therefore 301 is the 100th term. So this is a sub 100. So that is for this problem. Let's proceed to the next problem. Last problem for this kind of question. In the arithmetic sequence 106, 102, 98, 94, which term has the value of 2? Again, let's remind ourselves with the formula. Now let's enumerate the given. We have 106 as our first term. As you can see, the sequence is decreasing. So we need to compute for the common difference here. We have 102 minus 106. So the common difference will be negative 4. So common difference is negative 4. Now for the n, we don't know the value of n, but we have the value of a sub n. We know that that is 2. So now all we have to do is to write the formula, then substitute the value 2 for a sub n and 106 for a sub 1 and negative 4 for b. Now in this time it has a negative value of t, so please be watchful on how we do this. So we have 2 plus 106 plus quantity. 4 times n is positive negative 4n. Then negative 4 times negative 1, that is positive 4. So to eliminate this, let's distribute positive to this side. Then we have 2 is equal to 106 minus 4n plus 4. Now let's combine like terms. Okay, so this one will become 110 minus 4n. Now let's eliminate 110 here so that negative 4n will be singled out. So this will cancel. So we have here is negative 4n. And this part we have negative 108. So that is our new equation. Simplified equation. Now let's divide negative 4 on both sides to get the value of n. Then the value of n is 27. 108 divided by negative 108 divided by negative 4 is 27. So therefore, 2 is the 27th term. So this is the a sub 27. Okay. There reminder that the value of n should always be positive. So if you get a value of negative here, it, that means that you mess up your computation in this part, somewhere in this part. Please be mindful of that. N is always positive. Now, let's go to the next examples. These examples have different variety. and you need to have more patience on how to answer this. This has to face problem solving. So let's start first with the first kind of problem. Find the 18th term of the arithmetic sequence whose first term is 11 and whose seventh term is 59. So again, this is a sub 7, this is a sub 1, and this is a sub 18. We are asked to find a sub 18. Now again, let's remind ourselves with the formula. Then let's write the given. We have a sub 1 as 11, okay? And we have a sub 7 as 59. 7 terms. We we will use the value of n as 7. We will use this as a reference to in order for us to get the common difference. Because this is a sub 7 is equal to 59. We will use 7 as our values of our n, as the value of our n, because we don't have the common difference. Now let's solve for d. D is very important in order for this formula to work. Now, to solve for d, there is a special formula only applicable for this kind of problem. So that is the arithmetic sequence formula. Let's copy the formula first. Then let's substitute the value. Remember that our a sub n is our a sub 7. So therefore, the value of our n is 7. And the value of our a sub 1 is 11. Now let's try to eliminate first this to compute for this. So we have 59 is equal to 11 plus 6. So we have 59 is equal to 11 plus 60. Now let's eliminate 60. So let's subtract 11 on both sides. No, let's eliminate 11 in such a way that 60 will be isolated. So we have 59 minus 11, we have 48. So I have that. Now next is, we just divide both sides by 6. So to single out. So 48 divided by 6 is 8. So the common difference is 8. Now let's have our new given. We have our a sub 1 is 11. Now we have our n is 18 because it's time for us now to compute for the 18 term for the 18. The next, the d or the common difference is 8 because we just solved it there. Okay, next the a sub 18 is unknown. Then let's use the formula to solve for a sub 18. Then substitute all the given. A sub 18 to a sub n, 11 to a sub 1, 18 to n, and 8 to d. Then we have that 18 minus 1 is 17. So a sub 18 is equal to 11 plus 17 times 8. So 17 times 8 is 136 plus 11. So we have 147. So the answer for this problem is a sub 18 or the 18th term is 147. So that is the two-phase part of the problem in order for us to solve this. Now let's go to the more difficult kind of problem. The third term of an arithmetic sequence is 8, and the 16th term is 47. Find the 71st term. So let's remind ourselves of the formula. First, all we need to do for this formula to work, we need to have a sub 1 and b. And we don't have a sub 1 on this kind of problem. All we have is the third term or a sub 3 and a sub 16. Now let's work on that. Okay. Now I will explain the formula. A sub 3 is 8. That is our third term. A sub 16 or the 16th term is 47. Now I assign a sub 3 to be the a sub k, meaning the lowest given term. So this is the lowest given term. Then a sub n is the last term available. So we have k. We set a sub 3 as a sub k because a sub 3 is the lowest term that has a value. And a sub n is a sub 16 because a sub 16 is the last term that has a value, which is 47. So for now, let's solve for d and a sub 1 first. Because a sub 3 is a sub k, the value of our k is 3 and n is 16 because of this. So remember that. Don't be confused with this. So let's just solve for d by using this kind of formula. A sub n, the last term available minus the lowest term that has a value, then n minus k. Again, our a sub n is 47 and our a sub k is 8. Then the value of our n is 16 and the value of our k is 47 minus 8 is 39. Then 16 minus 3 is 13. So d is equal to 1339 over 13. So that is 3. So that is the value of our d. Now let's solve for a sub 1. Now let's consider this as our value. Don't forget that. So let's try this. Write it here. So, okay. Let's assign a sub 3 as a sub n. Okay, for now, we will use a sub 3 as our last term to solve this problem. So now the value of our a sub n is a sub 3. So what is the value of a sub 3 is 8. That is what. And we don't have a sub 1, but we have the value of n and we have the value of d. So let's try to solve this now. So we have 3 minus 1 is 2. So that was 8 is equal to a sub 1 plus 2 times 3. Then let's multiply 2 and 3. That is a sub 1 plus 6. Now we need to single out 1 here. So let's subtract 6 here. And we will subtract 6 also on the other side. So a sub 1 plus 6 minus 6 is a sub 1. Then 8 minus 6 is 2. So our a sub 1 is 2. So that is the value of our a sub 1 and our d. But that is not these are not what is asked on the question. We asked to find the 71st term. So let's go on with having this formula with us. Again, we have this given, a sub 1 is 2, d is 3. We compute that a while ago, is 2. And our n is 71, and a sub 71 is unknown. So for the solution, let's copy the formula, substitute all the value, then simplify what's inside the parentheses. Then after that, 71 minus 1 is 70. So a sub 71 is equal to 2 plus 70 times 3. So 70 times 3 is 210. 210 plus 7 plus 2 is 212. So a sub 71 is 212, or the 71st term is 212. That's how to solve this kind of problem. It's three-phase solution. Now let's go to the final problem. Now the given is already enumerated. A sub 8 is 5, a sub 21 is negative 60. Find a sub 17. Again, this is the lowest possible term. So this will serve as a sub k, and this is the highest possible, the last term that is available. So we have a sub n. So we have this formula, and the given are a sub 8 or a sub k is 5, a sub 21 is flat, or a sub n is negative 6. Then the value of k is 8 because of this. 8 is the value of k. and the value of n is 21. Now let's solve for the common difference in a sub 1. Again, this is the phase 1 and phase 2 of this of solving this problem, where we are not finding we do not we cannot solve for a sub 17 unless we solve for this. So let's solve for d. Again, use this formula: a sub n minus a sub k over n minus k. The value of our a sub n is negative 60 and the value of our k is 5. So negative 60 minus 5. Then the value of our n is 21 and the value of our k is 8. So 21 minus 8, so we have negative 65 over 13. Now let's divide 65 to 13. Negative 65 divided by 13 is negative 5. So we now have the value of d. Now let's use that to find a sub 1. Again, let's assign a sub 8 here. Let's assign this as our a sub n because we need to use a last term. We could use this, but we will deal with a higher number compared to 8 in solving. So I prefer to use a sub 8 as our a sub n or our last term. So let's so what's the value of our a sub n? We have a sub 8. Since that the value of our 8 is since that we use a sub 8, therefore the value of our n will change into 8. So that's why we change this into 8. And our common difference is negative. So let's simplify that. Negative 8 minus 1 is 7. Let's multiply 7 by negative 5. So we have 5 is equal to a sub 1 plus negative 35. Let's eliminate the parentheses. So in order for us to cancel this, let's add 35 on here. So a sub 1 minus 35 plus 35 cancel out. Then here we going to have 35. So therefore, our a sub 1 is equal to 40. So we already get the a sub 1 and the common difference. Now it's time for us to solve a sub 7. Again, the given are a sub 1 is equal to 40 and the common difference is 5. Now, because we're looking for a sub 17, we will consider this as our a sub n. So therefore, the value of our n is 17. Then a sub 17 is unknown. So for the solution, let's copy the formula. Let's substitute all the values that we have. Again, our a sub n is a sub 17. So because the value of our n is 17. So a sub 1 is equal to 40, n is 17, and d is 5. I forgot to mark this as red. So, but that's understandable. D is 5. So a sub 17 is equals to 40 plus 16 times negative 5. So 16 times negative 5 is negative 80. So we have 40 plus negative 80. And let's eliminate the parentheses. So a sub 17 is equal to negative 20. So I'm sorry. So a sub 17 is equal to negative 20. Again, because we have a negative common difference, the value should be decreasing or descending. So from 5, we have 0, negative 5, and so on until we get into a sub 17, which is negative. So this is wrong. I'm sorry for this. I did not edit this. Just remember that the a sub 17 is equal to negative 20. This is the answer. Okay. Thank you for listening and thank you for being with me and answering this problem. Now, this ends this discussion and hope you learned something today and watching this video. So, so for now, bye bye.